so 7.4. Section 7.4 is basic trig equation. I'm sorry, I'll try to write large. Let's start with the problem. Okay. I want to solve number one. So the first objective will be solve a basic trig equation. Restrict the domain. Maybe you appreciate my note, my printout note when you write these things down. All right, number one, I'm gonna solve the following equation, or the trig equation, where I'm gonna specify my domain. I want my theta gonna be between 0 and 2 pi, which is good. I'm sorry about the quality. Should make better somehow. It's very old machine. Part A, psi of theta equal 1/2. So here you can take a look at on the unit circle, right? So what angle gave you what angle theta gonna give you psi of 1/2? If you look on unit circle, I have 6, right? One more. There's the second quadrant. Yeah, so I see 2 between 0 and 2 pi, the two ones around. I see pi over 6 and pi over 6. Two solutions. You did this before. Isn't this? Part B, maybe it's a little bit more complicated. 2 cosine theta plus 1 equals 0. Let's solve that. First, I need to isolate everybody that around cosine theta, right? So subtract 1 first. So 2 cosine theta equals -1. Divide both sides by 2. Cosine theta equals -1/2. And then you look it up on the unit circle. What angle of theta give you cosine -1/2? -1/2. That is pi over 3. Oh, no, I'm sorry. No. Okay, 2 pi over 3. One more. The third quadrant. Yeah, 4 pi over 3. Maybe you have to get a circle and see. Not too bad, not too bad. C tangent square theta equal 1/3. Recall, if I have a in algebra, if I have say x squared equal 1/3, what do you do? How do I solve x? Yeah, I think square root, right? Plus minus, don't forget that, right? You do the same thing here. You take square root. It's like broad bread, I guess. Root, don't forget plus and minus. So the on the left side, the square and the square root cancel because they inverse functions. So just tangent theta. I have tangent theta plus and minus. So square root of 1 is 1, right? So square root of 3 is 3. So I have two scenarios. I have either tangent theta equal -1/3, or another scenario is tangent theta equal +1/3. And then you look it up on the unit circle. Let's do the -1/3 first. here. Yeah, I have here. Let's take a look. Oh, no, you can't see. Oh, no, my bad, you can't see. Okay, so, remember 10 is sine over cosine. It's negative, so it's gonna be either in the second quadrant or fourth quadrant, if you want those. Pi over 6, yeah? Pi over 6 over me. And one more in the fourth quadrant. What? 11, 5, and 6. And then you do the same thing for 10 to theta equal 1 over 3, that'll be first and third. 6. Tangent side. And 7, 5, and 6. Any question? Not too bad, right? Yeah, these are easy cases. Why don't you try this number of part D? Try this. I got 4 cosine squared theta minus 3 equals 0. What is it? One, just pause it. You do first. Yeah, this is just try to isolate the cosine. Then divide by 4. You get like at least 2 points to do that. Square, put the square. And then because squaring takes for the root. Just don't forget plus and minus. So I have 2 scenario again. I got cosine equal 1 positive 3 over 2. Maybe let's do negative first. Let's do negative. Cosine theta equal negative 2, and then cosine theta equal positive 2. And you look in the circle. Cosine. So what angle? Cosine is negative 2. I think 5, 5, 6. One more. It'll be quarter 3. 7, 5, 6. And for the positive case, I got 5, 6. One more. 7, 5, 6. Some exam which you will. So that is objective 1, objective 2. You're going to solve basic trigonometric trigonometric equation with unrestricted domain. This is harder. Unrestricted, but it's not too much. I mean, I don't have to tell you just to look at from 0 to 2 pi. It's gonna be, you're gonna go like around the unit circle infinitely many times. Then what is the solution? Before we do that, let's recall something. Remark. If you remember back in exam 1, what for sine, for one bullet point, for sine, comma, cosine, comma, secant, comma, cosecant. What is the period of these instead? The period Here it's gonna be 2 pi k, remember that? 2k pi or 2k pi. Let's do 2k pi. I think in the book they use n, but I don't like n because it looks similar to pi. Use k. Makes sense, right? One is around twice. So k would be 1, 2, 3, 4, 5, etc. All kind of negative. You do backward, it'd be -1, -2. And for tangent and cotangent, the period is just k pi. Just k pi. Period is just k pi. Now, what I'm not telling you this. So what you're going to do is maybe I'll show you one I have an example. Maybe it's easier. It's better that way. So this is from 5.3 and 5.4. If you want to look back. Number 2, solve. If I didn't say anything about domain, if I did not say between 0 and 2 pi, you know that it's unrestricted. So I got 2, let us take a look at this one. 2 cosine square. 2 cosine square x minus 7 cosine x plus 3 equals 0. It looks like, does it look like quadratic to you? Yeah. So maybe I'm gonna do this. I use black. Maybe I'm gonna let cosine of x is y. Let's do that. Then cosine square of x will be y squared. Let's rewrite that in terms of y. So I got 2y squared minus 7y plus 3 equals 0. You got comfortable with the algebra. Factor this. Y and y here, it had to be 2y times y, 2y squared. I need a 3 here and a 1 here, minus 8 1 times 3, negative y, negative 6y, negative 7y. So we check. So we'll check if the factor is correct. And what does this imply? What's imply? Imply what? This imply either 2y minus 1 equals 0, right? Or minus y minus 3 equals 0. Solve those. 2 minus 1, y is 10. Here, y is. Remember, we're not solving for y, we're solving for x, right? In this case, we're gonna plug that cosine x back for what? We let y equal cosine x. Now we're gonna put it back. I'm gonna use blue. Put it back. So put cosine x back. Now cosine x equal half, cosine x equal 3. Then you can look it up on the unit circle. What angle of x cosine is 1/2? That would be pi over 3, right? I saw 1, pi over 3. What else? Go down. No, don't comma. Go down. One more. And 5 pi over 3. Thank you. 5 pi over 3. Now that is just a solution from 0 to 2 pi, right? What if I asked you to do one more? And one more and one more. You don't want to keep listing it out for me. It's never ends, right? So, well, let me mean. How about 2k pi? You choose your own k. You go. So that is the general solution for all the eternity, right? For all the infinitely many times you go around that in this circle. That's why we talking about the period of cosine sine. You need to memorize. You need to, if you forgot, you need to know this, or at least memorize it. So on the exam, you know what to add to. From here, I'm gonna say, we're gonna add 2k pi. From here, we're gonna add k pi cotangent and tan. That's what I did, that's what I did. Now, the second case where cosine of x equals 3, what do you think? I cannot look this up on unit simple, but I can take inverse, right? You can do inverse cosine. What does the calculator tell you? Well, the left side can so h, but the right side, what does it tell you? You plug your calculator in this. If I plug in my calculator, let's see what it's domain error, right? Remember why is that? Why is that happening? Do you remember? It had to be between from what to what you always take the cosine first. Negative 1. And you are way out there. Remember we cut that chunk, so it won't, it passed the horizontal line tab, remember that? So we cut that chunk in the middle. So yeah, it's out of range because 3 is way out there. 3 is not between -1 and 1. So no solution here. Well, you have a solution. You have two of them. Okay, that's how you solve the trigonometric equation with unrestricted domain, right? All you do is add 2k pi or k pi in terms of tangent. We're not gonna do the, when I post the note, you're gonna see the story problem. We won't do that today, please. I'll delete some of the homework problem on 7.4. B. I got 5 sine of x and then cosine of x plus 2 cosine of x equals 0. I need to solve that. Any suggestion? Any suggestion? Just intuitively? What's the first thing I should do? Huh?
But how we
No, we're not combining, but we can, actually opposite of combining, what do we do? If I have x squared minus x equals 0, what do you do? No, you don't add the x. You add the x and you divide both sides of the x, you're losing a equation solution. You factor out the x, right? Does it make sense? And so either if this is 0, then either x0 or x1. Okay. And you can say in here, we factor out. Factor out. Factor out. Remember, this is multiplication, this is multiplication, not multiplication, right? It's of the cosine of x. So factor out that, I got 5 sine of x plus 2. So either cosine x equals 0 or the second chunk equals 0. So 5 sine x plus 2 equals 0. Cosine x, well, just from 0 to 2 pi, what angle of x will have cosine 0? So that implies x is pi over 2, right? I see pi over 2. What else? Yeah, pi over 2. And all you have to do is what? What do you have to do? Because it's unrestricted, all you have to do is add 2k pi unit. It's pretty much the same thing that we did in restricted domain. The extra stuff is just add to paper. So 5 psi x equally to the subtract 2 cosine. I divide this by 5. Question, can I take inverse? Would be out of domain. It won't, right? Negative 2 to the negative 2 fit is inside the domain. So okay. So x equal. Let's plug it. Yeah, let's do this. Sine inverse of negative 2 divided by 5. I want in radian, okay? Let me talk okay. I want in radian. Maybe 0.4, 1.15, something like that. And then you add 2. Is this a complete solution? Is this complete? Yeah, your quiz 2. Back in exam 2. Sine inverse is what quadrant? The 2 is what quadrant? 1 and 4. I want you to find the angle of x. Let's talk about the original problem. So that was the original problem before we add the sine inverse both sides. So I want you to find the value of x, the angle x, such that when you plug it into the function sine, the outcome is negative 2. What does it mean on unit circle? So whatever the angle is, right, your outcome is negative 2 So negative 2 is right here, right below. Remember what we do? Remember this? Remember that? So one of them will be there to there. And the other one is I'll use green, and the other one is right. 2 of them. So in order to find this one, what do I have to do? I'll take what? I'm trying to figure out a way to explain this to you without confusing you. So we found the green one, blue one. We found the blue one. Great. We just have to find the green one now. Going to be the green one is going to be 2 pi. Subtract this little tiny bit, yeah. Right? 2 pi. It's almost 2 pi. Just except the gap is right there. So 2 pi subtract that gap. But we don't know what that gap is. We don't know what that gap is. And that gap is right there. It's just a positive, not the negative. That gap, if that's how much that gap is going to be equal to. So in order to find that, all you have to do is make x this 5 plus 1.15. But don't forget the answer. So that is just say on the exam you miss one solution, you only miss one point. So understand the steps, not easy. But at least get to this point, okay? At least get this one. Use calculators. C, I got tangent x minus 1 equals 0. We're almost there. We two more problems more algebra. Add one. One. But I want you to tell me what, at least from 0 to 2 pi, tell me what angle of x tangent is 1. Tangent is 1. What angle of x tangent is 1? It's positive, so either quadrant 1 or quadrant 3. So pi over 4 and sine and cosine the same thing. Yeah, pi over 4, right? Sine divided by sine, they both the same thing, so. And then we're going to add. What's I'm going to add here? 2k pi or k pi? K pi, right? Don't forget k pi. Be mindful. K pi. Done. It's slightly, like it's slightly a little hairy. It's D. 3 secant square theta. I'm sorry, minus 4 equals 0. Subtract 4 equals 0. So what you need to do, add 4 divided by 3. So secant square theta. 4. Sorry, 3 secant theta. Now divided by 3, secant square theta. There's no square. No, there's no square. No, I'm changing it. I fixed it. Oh. Yeah, that's from, what do you? Oh, really? Oh, oh my God, oh gosh, I had to type it again. So on my computer, I messed up. Yeah, I must have to actually paste the forms. But luckily I had a copy on Google. Thank you, I'm gonna do that. So I had to like type it in. Yeah, fix it, second square thing. And then you want to solve, so you have to take the square root of both sides. So I got secant theta equal plus and minus what square root of 4 is 2, 3. I have two scenarios here. I got secant theta either negative 2 over root 3, or secant theta is positive 2 over root 3. Now, it's you don't want secant. You can't look it up on unit circle. Can I change it into cosine? Remember, secant and cosine, they are what? They're reciprocal, right? So all you have to do is if you flip it, into cosine, you're gonna flip the fraction. So cosine gonna be negative root 3 over 2, and down here cosine is positive root 3 over 2. But they're reciprocal, which you see what angle theta cosine is negative root 2. Simple. I see 5 5. I see 5 5. Is that right? 5 5 is 6. Same thing on. One of them is 5 5, the other one is 7 5 over 6. Right? I'm talking about the negative case here first. And all you do is don't forget add 2 here. For the positive one, theta must be first of all 5 or 6, and then the other one will be 11 5. I'll make it easy for you on your exam. I'll make sure you'll be able to look it up on YouTube. Okay? So you don't have to run into them. You don't have to run into this. So it's easier for you to look it up. Get your algebra straight. One last one, we go home. E tangent cube theta equal tangent theta. What do you say? What should I do? Help me out with this. Should I divide both? I have, if you think about it, I've got 3 copies of tangent here, and I have 1 copy of tangent here. So it's in algebra sense. If I were to translate it into algebra, it looks like this. I got x cubed on the left and then x on the right. What would you do? Huh? Should I divide both sides by x? Oh, you don't. Why don't I don't want to do that? Say you want to divide both sides by x. Well, that's great for the x squared equal 1. Oh, that's easy. Take square root both sides. X equal plus minus 1. How many solutions do you see? 2 solutions. But the original problem telling you that it's a cubic, so it should have 3 solutions. Fundamental theorem from should be 3. So do not do that. By doing that, what do? You losing a solution. Right? And what if x? You can't do that either. What if x 0? You can't do that, right? You can divide by 0. So you don't divide both side by a variable. You don't know what it is. What if it's 0? So what we're gonna do is we what? What we do? You know, we do what we do best. We subtract the other side and factor it out. So tangent theta, subtract tangent theta equals 0, and then you can factor out one of them. Tangent theta. Let us see tangent squared theta. So that means tangent theta equals 0, or tangent squared theta minus 0. First, we talked about this before. Tan 0 is when theta 5/2 or theta equal 5/2. And all you do is add a pi. Over here, we have 1 side. Now you can take a square root. So that's just scenario, I have tangent theta equal 1, or tangent theta equal 1. See, if it's -1, then theta must be either 1/2 or 4. So for the negative case, theta is going to be either 3 pi over 4 or 7 pi over 4. You look it up in this. Second, for the positive case is going to be 5 over 4. Can you do this on the exam? Do that, right? I'm going to go into the other side and delete some stuff. I'll delete all the story problems.